Hey everybody, Dr. Nelson here. This is a video about exponential decay functions, alright? So maybe you've already learned about growth functions. This is kind of like the opposite, alright? So take a look at the equation. We have y equals a times b to the x, okay? And just like the growth function, the a value is the starting value. So let's write starting value. Okay? But the b value, okay, is going to be the decay. So for growth, the b value was for the growth, okay? But this time, the b value has to be less than 1. All right, that's the big difference between growth and decay. Where growth, the b value is greater than 1, while decay, the b value is less than 1. All right? Over here, we have an example of an exponential function showing decay, okay? And I want you to focus on the y values. And notice as the x values get larger, okay, the y values get smaller and smaller and smaller, okay? That's a sign of an exponential decay function, all right? So again, the y value here is 9, right? The y value here is around 5, okay? The y value here is around 1 or so, okay? As the x values get larger, the y values get smaller and smaller and smaller and smaller and so on, all right? So now that you have a good understanding of just what an exponential decay function is, why don't you pause the video and try the your turn problems now, and then when you're done, hit play and you can see how you did. All right, good luck. All right, welcome back. So for these problems, you have to identify which functions really show decay, right? Okay. And again, just a reminder, the formula is y equals a times b to the x. Okay. And again, the most critical thing about this is the b has to be less than 1. All right. So over here we have y equals 3 times 9/10 to the third power. And because 9/10 is less than 1, this is absolutely a function that shows decay. All right. This one here, again, look at the y values. Okay, the y values are getting smaller and smaller and smaller, okay, as the x values are getting larger. So this is also a decay function. Okay, this one, the y values are getting larger as the x values are getting larger. So this is actually a growth function. So this is not a decay function. Here, this is also a decay function because, again, look at the lines going downward, right? And the y value is getting smaller and smaller and smaller. So this is also a decay. And last but not least, we have y equals 5 times 1.2 to the fourth. Well, 1.2 is greater than 1. So this would be that of a growth function, not a decay function. Okay, so that one is a no. All right, how'd you do?